Hello friends, in last lecture we discussed the condition for steady state oscillation and cavity of resonance frequency. So today we are going to start the new topic, line broadening. So in this mechanism we can discuss about the various types of mechanisms, line broadening, natural broadening, collision broadening and Doppler broadening. So first tell you about the line broadening mechanism. In this mechanism, an atom uh, absorbs the light frequency at which absorption or emission can be takes place. So this process can be given by V0 is equal to E2 minus E1 upon H. So in this equation we discuss the in discrete energy levels of E2 to E1. Discrete energy levels of E1 are infinitely narrow and the atomic transitions from level E1 to level E2 can be occurs as a single definite frequency mu 0 V0. So in this way we can light energy emitted by atom is not strictly monochromatic. It modify our visualization of energy levels. So in this energy level will be can be defined as the that assume that energy levels of E2 and E1 are cannot be sharp lines. So it can be spread a range of energy from DE1 DE2 to DE1. So in this mechanism, light emitted atoms in the form of waveforms, and that exponential of damping can be the exponential of damping amplitudes will be generated. So intensity of light can be plotted against the frequency from. So it can be defined the curves as shown in the figure. See that the E2 is energy and the first excited state, and see ground state energy. This will be exerted the energy light emitted, then frequency form of energy will be defined as. So in will be it will be defined as E2 curve in the curve of formation E2 minus E1 upon H is the intensity of light, and is V is denoted by the frequency. So in this way we get the that the transitions of light emitted from the frequency spread in dV form. So figure shows that we can define the line broadening mechanism by describe the line shape of function g of v. So in this line broadening mechanism can be defined as by two types. First is a homogeneous mechanism, and second is a inhomogeneous inhomogeneous types of line broadening mechanism. If the broadening mechanism effect as an individual atom, the sample can be formed in the same extent mechanism. That broadening mechanism affects each individual an atom of sample to the extent form is known as the homogeneous mechanism. So in the for example, natural and collision broadening is the most popular examples of homogeneous mechanism. That and in such case the atoms can be defined as the frequency mu 0, and sample will be defined as in the form of line shape. So second type is a non-homogeneous mechanism. In this mechanism we get the different atoms in the sample wave slightly different frequency for the same transition can be generated. So the sample of broadcast mechanism, we get the frequency for the same transitions can be occur, and that in case of overall response can be broadens out, and they will be that will be broadening mechanism in the form of that inhomogeneous form. So different atoms in the sample have slightly different frequency for the same transition state. So in this state is known as non-homogeneous broadening mechanism. So for example, Doppler broadening and broadening due to crystal defects is the most popular examples of non-homogeneous broadening mechanism. So in this way we can prove the line broadening mechanism. How to, in this mechanism, how to light emits and generally absorption and emission phenomena takes place in the form of energy, and so in this way we can prove that the line broadening is a mechanism. Next mechanism is a natural broadening mechanism. In this natural broadening mechanism, we see that the energy levels in an atom are not in really sharp. So energy levels are excited state for an infinite length can be defined according to Heisenberg uncertainty principles, gives the delta E delta T approximately H. So it will be defined as the leads of that impossible of conclusion atom stay in excited state, and infinite length can be defined as the in the form of delta T tends to infinity and del tends to 0. So the here we get the uncertainty principles required, that energy can be spread in terms of frequency. So it will be denoted as delta V is equal to 1 by T. So in this case the upper state have mean lifetime and of order of 10 raised to power minus second. So the spectral arising from a transition from an excited state to the to that of ground state. Frequency spread in the form of order, we get delta V is equal to 1 upon 2 into 3.14 into 10 raised to power minus 8, means it gives the 16 mhz. So it will be in the form of megahertz from frequency we get. So in this way the natural broadening is relatively small in magnitude, and that mechanism is oftenly say small amplitude will be denoted. So in this way we can prove that the how can be natural broadening work in the work out in the form of frequency mechanism. So in this way we get the we can be discuss the line broadening and natural broadening process. So thank you.